Now it's recording.
All right, so let's resume. Okay, so this is where we stopped in part one.
Yes.
All right, so the other extra that we did here, this is not really an extra. This is now core of the project because it's an important part of it. We found that 5,707 trees have a known location, so they have longitude and latitude, but had no known neighborhood. However, we have the polygons, we have the data shapes for the neighborhoods. So we did a script to find if any of those trees were located inside of those shapes, inside of those neighborhoods. After running that using Django's um, standard ORM features, we were able to reduce the number of orphan trees to 160. Now, for those 160 trees, we allocated them to unknown neighborhoods within a specific locality. So we created these records because this relationship does not accept any null values. So that's how we handle that. So we still have 160 trees that have location, but for which we have no polygon. In the early stages of the backend development, created a data exploration rather than analysis, a data exploration report available in HTML and TXT to see the shape of the data that was incoming. And so we could start planning for different types of data integrity measures and so on, constraints and so on. I said earlier that we were going to have a quick look at GitHub. And all there is really to say here is that GitHub was leveraged extensively. The issues, so we tagged issues by different types of, by type, task, whether it's a task, a bug, a feature, a new feature, request, and then created branches, feature branches, worked on the development out of our own forks, and then open pull reviews. So this is more or less the flow that we used to collaborate on this. The main contributors to Django code are myself as the task lead and main contributor, Cindy Lorena Quecan, who contributed tests for the multi-string representation methods, and Sebastián Duque, who contributed the Spanish translation and internalization, in addition to the work that he did with the data science team. Now we can move on to a demo. So here we have the admin. There really is no front end for this. So if you were to go to the home page, you're going to find nothing there because this project was API first. So you're not going to find anything there. So you go to the admin, and here's where you can, for now, just hack the URL and change the language. If you want to look at this in a different language, English and Spanish are the only two available. I'm going to show it to you in English. So in the admin, the Django admin that we customized extensively, you're going to find, well, all of your auth and authorization permissions. This is standard Django. Comes from Django all auth. And here's where we get into our own stuff. So biodiversity records, this is what I consider the central model of the entire application. This is the trees themselves. Here you can navigate the trees by the date in which they were recorded. Some of them in 1899, some data to clean there. By life form, by locality, and then each one of the trees will have a common name here, for example. We have a total of 96,000 records. You can actually show the count here. And you can see the total is 96,943. records. Here's the leaflet integration, and this you can edit directly here. You can even delete the features. You can. This is a complete CRUD application. The way the Django admin is. This is of course the super user view. You can customize different groups, roles for different people if you wanted to have specific scientists, users, etc. You can customize all of that quite easily using Django. And neighborhood that it belongs to. So here we see the main foreign keys that this table has. All right. Then, of course, countries, you're only going to find one. Departments, just one. Localities and the city, municipalities, just one city. So we have for now one country, one administrative division within the country, department in Colombia, province, state in other countries. And then each city is going to have multiple localities. So you see there's just 14 localities, including the unknown locality, which is where we are allocating anything that we don't know where it belongs yet. For the neighborhoods, we have the actual neighborhoods. Can't remember how many we have here, 500 or so. Maybe that's too many. 700 neighborhoods. There you go, including a bunch of them that are the unknown neighborhoods for which that we created to allocate the trees with an unknown neighborhood. Measurements, these are quantitative records, and here you can explore the measurements. Here's the related location for that measurement, and so on. Observations, this is the one that has a lot of data. I think I navigated by mistake to the, when I was in measurements, I navigated by mistake to the record. Yeah, so here's the measurement. And here's the observation. This is the correct way to access it. Connected to a specific biodiversity record. So these are observations and measurements for a specific tree. And you have a bunch of technical measurements. All of these is coming from the data. Some of it is populated, some of it is missing. And all of it is encoded like this. So this is what I mean by data integrity. It's not going to accept values that are not encoded in Django by default. Functional groups, other types of measurements. These are the species level, if I remember that correctly, and so on. So this is what the admin looks like. Allows for easy exploration of the data and changing the data and adding data, adding countries, adding everything here. Now, as long as it conforms to the data shapes that we've created, it will be there. PG admin, this is where you can explore the data in a tabular format. So you can see anything that is available, all of the Django tables, all of our own tables, the observations, of which there are 96,000 for each tree. You can explore all of that here. You can do your own SQL queries as well. That's available within the container for convenience. I'm going to leave that one for last. And here's the API using Swagger. And you can see here how you can interact directly with the API. So you can use the filters, ordering, paging. It's a very robust, very complete API. It is ready for building a very powerful front end, whatever needs to be done. It has some really cool features, like, for example, searching the records by locality, neighborhood, of course, but also by bounding box. So you can pass to the API picture like it's a rectangle. Give me all the trees within this minimum longitude, maximum longitude, latitude. You create a square, so a picture that you could be on a mobile device and do this query and show me 300 trees that are around me. So here's how this is ready to go for a very, very powerful mobile front end or or any other kind of front end that we want to build in the future around this. That bounding box is probably one of the most exciting things about this API. Records near, this uses, again, GeoDjango's framework, where you can find within a radius, and you can also filter by limit and so on. So it takes a parameter, distance. So show me trees in a radius of 1,000 meters, for example. So you have the polygon, the shape, and you also have by distance. So very, very useful stuff. All of the climate data is there by station. Same here. We use the geographical data to nearby stations, probably a little bit less useful, but everything in here in the biodiversity was very well thought out, and it's quite comprehensive. And here is the rest of the API definition. Each one of these is an endpoint. All of these are endpoints that are ready to accept data queries. Here are the different schemas. So the enums that I mentioned earlier, and here's what you can pass to an enum, for example. These are the only records that it will accept and it will return. So this allows us to keep the data quite integral, and so on. So this gives you an idea of how the backend is all coded. Just by exploring the API, gives you an idea of how everything is coded in the backend. And then, of course, we have our token-based authorization, so session-based and token-based, and we also have different types of authorization using JWT. So secure by default, as Django is known for. You can also explore the API with Redoc. I personally prefer Swagger, but here you can do the same thing, interact with the API in this format. It's just another way to interact with the API. And then the last thing that I'm going to show here is the tree of life visualization. So this is a database that lends itself to some quite cool visualizations. This one was done just for fun, to see what it would look like. And here's the taxonomy. So as you hover over each one of them, and of course this requires a lot of work to make it look more presentable, more usable, but you can already see the potential that this has for creating something really cool here for the front end. And this is all done in a single JavaScript, in a single HTML template, just simple Django template with the JavaScript and the CSS embedded right into it. So with a more advanced JavaScript framework, wonderful things can be done. This is it. This is the application.
Thank you so much, Felipe. So after this explication about the backend and all the features, all the tools that we have here, I want to show you like the final delivery that we have in mind, right? And how it looks like for the final user, correct? So let me know if you can see my screen there. Okay, nice. So we have here, like we have told before, correct? The frontend was implemented using Angular, the frontend, correct? So all this information, all this data is using the backend, okay? So I want to show you like a little example about how it looks like, okay? And let me place this one here, and I want to show you. So this is the first of all, the first component that we have here is the dashboard of the city. So we have a count about the total trees that we have. It is 96,000, almost 96,000 trees inside of the data set that we have. Inside of this 96,000, we have 459 species different. and the average of the height of those trees are 17 meters. Also, this is a useful index. This is 3 per capita. And this index showed to us that for each 7 person, it will be 1 tree in the city. For a health city and for a good performance in the ecosystem service, it should be one or two trees per capita. It will be the best. It will be the best way to handle the health in the city. So according to this information, we are very, very far away to this achieve, to this goal. Okay. But this kind of dashboard is very useful to the people, to the any kind of person see the state of the urban tree so far. So we have, for example, the amount of trees that need attention, the amount of trees that are healthy, the amount of trees that are critical. So all these kind of things are available for the public. Also, there is like other integration that so far is like illustration, but all this kind of analytics or trends, it will be in the future, it will be adapted to use the API that Felipe showed to us. Okay, so this is how it looks like in the front end, and in the future, it will use, for example, these records. In the future, it will use a real-time data using the API. Okay. Also, we have here inventories, the section of inventory. The idea will be like in the future, a person use the function of add tree, or even they can export tree using filters. So this is a user-friendly way to interact with the urban tree. Also, we have reports with the type of inspection, the ID of the tree, the status, and action that we can do. Also, we have here alerts, correct? The idea will be integrate these alerts with those critical trees that there are inside of the urban tree information. And we have here like information about the project, who are we, or mission or overview about the project, use case, like for example, urban planning, environmental research, management of the urban trees, and we have here a section for in the future at the sponsor that want to participate with us for the research and the maintenance of the urban tree. Okay. Also, this is a very interesting environmental services. Okay. For example, the first one is the CO observation or the carbon sequestration. So according to our records, for all the trees that we have inside of the urban tree, this is a real data that we use using pgadmin. This data show to us that we have around 600,000 tons of carbon, and we have oxygen production around 1.7 million tons of years. So this is not a perfect model, but these provide to us like a review about all the things that the urban tree do for us. Okay, so this is a lot of tons of carbon, and this is a lot of tons of oxygen that the urban tree generate to the city. Okay, and finally we have other final dashboard for the for the for the trees. Okay, so this is like how the final presentation for the final user looks like. The idea, oh, I'm sorry, let me show you the last one, like the most important thing that I believe. This is the information, the map visualization here, correct? So the idea it will be in the future we can see the the data of the neighborhoods of the urban trees. For example, this is a real-time integration. We use, for example, the API of the, for example, Comuna is the name of this geographic section in our city. So these polygons, we are making a request for the API from the backend, from the database. So the idea it will be in the future when we create a zoom, we can split the comuna in barrios or neighborhoods, correct? This is the like the localities. So the localities it will be split in neighborhoods, and then the neighborhoods it will be split in points, correct? It depends about the zoom that we will use, okay? And the idea it will show here, this panel, it will show the the amount of trees that we have in each common or locality or neighborhood or that's it. And also when we have the data point view, we can see here the information about each data point in our city. Okay, so that is how the uh, website work, how the project showed the information, and we are not we are making a really big progress in the integration of the data data cleaning and visualization of those data. So in this section it will be like the final thoughts. I want to share with you that I am very happy to be here and make the progress until here. It is a lot of work, and we create a point of a start to create a platform really big and something that create value to the people. In the develop of the Angular frontend, I know that Angular is not like the best framework to handle a project. Also, we have other framework like React, Vue, well, other than I don't remember in this moment. But it always is good learn a new technology to see the benefit and the advantage that they provide to us and the challenge that this technology provide to us. So is I think that was a very good exercise. Use Angular to show this front-end visualization. And I want to, for example, ask to Sebastian, what do you think about the front-end development? What do you think about Angular? Which other technology you can suggest to new developers? Uh, all these kind of things about the front-end uh, thoughts.
Okay, yes. First, my own introduction. My name is Sebastian Duque. I am a backend developer for 4 or 5 years now, and I also studied data science. That's why I did the data cleaning process. About the front end, well, I'm not an expert about that, but I can say that this kind of frameworks are very useful because of the reusability that they provide, and and especially Angular, I like that it works with TypeScript out of the box. I prefer TypeScript over JavaScript, but just that's just a personal preference. And as you say, there are other frameworks like React, Vue, Svelte. There are others that do similar things. But like I say, I'm not expert in the area, so I can recommend one over the other. But what I can say is that using a framework for front end saves time programming a lot of things that already have been invented and programmed. You mute.
And sorry, thank you so much for your words, Sebastian. So, to continue with the process, Felipe, can you share with us your thoughts about why Django is important to the developed world? What do you think that is useful? Why you like Django? I have used Python for the Django too, but not in the same way like you, because you have like a big background in this. I have used the most of the time Python for the data clean, for the model process, for the geographic process, geographic analysis. But tell me, why did you decide to use the Django for this project and in your project? Do you, why, what is the most important thing about Django that you like it?
I didn't choose Django.
Well,
You did.
we were,
And that's
well,
why I joined this project, because I saw
okay.
Django advertised.
Okay.
um, yeah, well, it's the only framework that I've used really, but I chose it early on, when I began developing, and I wanted to get into backend development. I briefly reviewed everything that was available: Spring, Laravel, the very popular Ruby on Rails. And I chose Django for a number of reasons, because I love the Python language. I very early on recognized the importance of the admin, the value of the admin. I thought that it was really cool to have something, a CRUD interface that you could just start interacting with data right away. As soon as you build your model, you can already start creating records, all of that, without having to touch the database directly. Um, Mature is a very mature framework. It's 20 years this year. It's turning 20 this year. So that in frameworks is a lifetime, is ancient, which means some people call it the boring technology, and because it's just been around for so long, it's difficult to contribute to that project. It's famous for that. It runs 17,000 tests. Um, it's incredibly robust. And what I found through this project, I had never used two features of Django before: the Geo Django features, the GIS features. I was very impressed with it. It's amazing what you can do, the queries that it allows you to do. What I was showing you in demo, right? The ability to do a bounding box, distance, the storing polygon shapes, multi-polygon shapes, and and we just scratched the surface of what it can do. It can do so much more. It is it aims to be, if you read the documentation, it aims to be a world-class geographic information system development platform. And I think it is there. It is amazing what it can do. And by adopting an API first approach, that's also a first for me, because I've typically worked within Django with Django templates, and rather than serving a front end using API first. So that was also learning curve for me. Very exciting to use Django REST framework for this. And as you can see, it's extremely powerful. We haven't looked at any of the code. It's available there for anybody who wants to see the code, but it is incredibly powerful. And once you learn some Django, it's all very intuitive, the way Django REST framework integrates with the rest of Django. And Geo Django is core Django. There's nothing there that is an external library or anything like that. Supported by external libraries. Also very exciting to work with Docker, having everything Dockerized, having everything containerized. Even then, we had some issues that we had to navigate through with your system, with Sebastian's system, with somebody else's system. the front end guys' systems. Yeah, we still had to troubleshoot there a few times with Docker, but for the most part, it worked very well for a multi-developer experience. Yeah, very happy with having used Django here. I couldn't have used anything else anyways, because I don't know anything else.
Thank you so much, Felipe. That is very, very good words to the project, and I am totally agree with you. I have learned a lot with this project, with you, with Sebastian, with the front-end team, with the data clean team, with the data search team. We know that our time are flexible, but all not the people had the same time or the same dedication, but all the people that participate in the project try to apport in the way that they can do it. So uh, maybe not all the team are here in the presentation, but I know that they work really really hard to do each feature that today the project has. So I'm really really proud about all the person that was involved in this project. Um, and I am proud also to the project looks like so far. So has a robust API, a robust backend, has an initial frontend. We have really good visualization. I think that for the most of the people that are not in the developed world, like in the normal world or the community, for the people of the community, they will see this and it will be useful. Has this tool for the city. That is the most important. We are creating a tool for the city to make a better, to create a better decision maker about the urban tree and the forest mass inside of the city. So this is a really, really good point to start. And I hope that in the future we can contribute and continue with this project in a really, really big scale. Okay, so thank you so much, Felipe, to be here. Thank you so much for all your support and all your effort. And thank you so much, Sebastian, for being here and all your support too. And thank you so much for all the people of the Ondena team, for the project of the Urban Tree, and all the people that are watching us in this moment and in the future in YouTube. Okay, so thank you so much and have a wonderful day.
Okay, thank you.
Bye bye, team. Was
Bye
a
bye.
pleasure work with you. Bye bye.